So by this, what we can see is simultaneous recording is simultaneous performance is being done. So now, if at any point, if at any point one system goes down, other systems other systems are available for the same task. Okay.
Mm.
So here, this is the second thing, that is replication, right? Um, the first point, the second point was the high availability. Means due to this point, if any system goes wrong or something happens to any system, other systems are available. So maximum number of time your system will be available for the job. Second thing is replication. So replication is a service where where replica of each system is available on other system, right? Replica of each system is available on other systems. So once any system goes off due to maintenance, any system goes off due to maintenance, others other available systems will take care of that job. Okay, so that's what is replication. So when you will be working on like a big data, or you'll be working on the cloud system, so at that point of time, what it does is, at the very initial phase, what it does is copy of each VM machine is always available on each other node. So what will happen? Like suppose we have the machine one, and we have the machine two, and we have the machine three, and we have the machine four. So at any point of time, right, most of the time, all these systems are up and working. All these systems are always up and working. But at any point of time, if let's suppose M1 goes down, right? So copy of M1 is available on M2 also, and M3 also, and M4 also, right? It's not just that copy of M1 is available on just M2 or just M3 or just M4. Copy of M1 is available on all other available nodes. Okay, like if M3 is there, so copy of M3 is available, replica of M3 is available on all other nodes, right? So if anyone goes wrong, or let's suppose if all three goes down, then M1 will take care of the responsibilities that are being done by M2, M3, and M4 at any point of time, right? So there can be a delay in the response, there can be a slower process, because what four systems together are doing now, in only one system is doing. So there can be the delay possibilities with M1, but the system will be up and running. Okay,
Okay.
right? And this ensures the high availability. Okay, so this ensures that 99.9999999% times available. Okay, most of the time, 99, maybe, because 100% nobody can promise. There is a possibility that systems can go wrong at some point of time. So 100% availability, nobody can commit in this world. But this high availability, Mm, okay, sorry.
Mm.
Okay. Due to this high availability system, system promises the 99.99 percent times availability. Okay. So this is the third point. This is high availability was the third point. And then the fourth point is the distributed frameworks. right? So in distributed frameworks, what happens? In distributed frameworks, so once when we were working for the banking data, when I was working for the banking data, so on that, what used to happen? We were working on the CCAR and CSIL model, right? Right. So here a lot of loan related data was there. So loan related data, like there are home loans are there, or there are the commercial loans are there, or vehicle related loans were there. Okay, so lot many loan data were there. Now, when we have to calculate the performance of the model, so there may be the multiple loans which might be running for 20 years. Now, for the 20 years span, we need to calculate the risk of the loans, like there can be the defaults, or NCL or GCL we need to calculate. Okay, so while this calculation, there can be many number of loans, and all the number of loans are calculated on many number of parameters. Now, what earlier when we were working on the not on the distributed framework, so what used to happen? When we were running the model run itself used to take 4 to 5 days. One model run used to take 4 to 5 days, and like that. So one model used to take 4 to 5 days, and there was that too there with no manual intervention. When everything is set up as the parameter, everything is set up, so one model used to take 4 to 5 days. And like this, we need to execute the models for different locations. There were the different geographical areas were there, like I was working for the Mexico was there, then for US, and then for the um, Costa Rica and all, and Singapore. So for different locations, each model used to run separately. And when we were running these models, the huge load was created on the server, because one server it was on one server only SaaS was installed, and everything was working on that part only. Okay, so what later on what we did is we applied the distributed process right? So now is what we were doing is, instead of sending the data of around let's say there are 2 crore loans are there, 2 crore loan accounts are there, so instead of sending all the 2 crore loans through one process only, what we did is we divided, means not physically we divided in the entire data in part of small chunks, like 10 lakh loan accounts were in one chunk, and all 10 chunks were processed separately at the same time. So at that by that what happened, like the process that used to take 4 to 5 days for one model, this got reduced from 5 days to one day. Means today I have run the model, and tomorrow the model got completed. So by this way, at this because now the entire data is not going at once into the system. Rather, it is the same data is going at the same time it is going, but the data is going into the smaller parts. So when data goes into the smaller parts, now it becomes easier for RAM to catch the to create the separate cache for the each process.
Mm.
So when data used to go from just one server, there were the chances of crashes. But when many servers were involved and many processes were going through the through virtual machines, so at that point of time, the overall process was simplified. So that was the one thing. So by distributing this, the overall process became lighter for the server. Okay. Then the second issue that we were facing was like when we have done the model, and then we need to wait for 4 to 5 days to complete the entire model. At any point of time, if any node got failed, or any technical error has come, or any account error has come, what we need to do is we need to again run the entire model for next 4 to 5 days. So again, we have to wait for the 4 to 5 days if any single error comes, right? So this was quite challenging. Sometimes the time that we would require is that let's suppose I need the report by since let's say today is Monday, and by next week I need the report by Friday. Now I have run the model on Monday, and my model is getting completed by Friday. And if everything has gone perfect, then by Friday evening, all the data will be available, and then I can use that data further for the report calculation. But at any point of time, let's suppose on model started running on Monday, and it has got failure on Thursday. So again, Thursday I have to start the entire process, and then now the model will run, and the run will be completed by maybe Monday or Tuesday. So now I have very smaller time, and if in this uh, part again, if something got failure, we will not be able to provide the report because the model has not run, because every time I have to run the entire model. But when I am running the same model into the small chunks, like 10 lakh record, 10 lakh loan accounts I am processing at a time. Now, let's say there are 8 models are there who have run very fairly. There was no error, and there are two chunks are there where the running has been failed. So now I don't need to run the entire 2 crore record data into the model, and I need to just run those two chunks which have got failure. So now it was easier for me to rerun the smaller model and get the result very quickly. So like when I am
mm,
running the 20 smaller chunks at once, it is taking 1 day to get completed. But when I am giving just two chunks to run, it will be completed maybe in just 6 hours. In just 6 hours. So overall, the model working got simpler. Okay. So this is the advantage for fault tolerance. So if
okay.
for instance, if any one node, if any one node gets fail or crash, then it is easier to target just that part. Okay, understood?
Yes.
Any doubt with this? So this is what is fault tolerance process. Clear?
Okay. Yes.
Are you able to understand the concept? So this
Yes.
is this is with this fault tolerance. Now, next very important part, that sixth part is the partition of data. Give me a second. My phone is getting discharged. Let me connect. Give me just few seconds.